Hello, welcome to our talk. Xtext and Sirius strategies and pitfalls. This is Cedric.
That's right.
I almost forgot your name.
I'm Cedric Brown from Obeo and CEO at Obeo. We are building Sirius in Eclipse, the Eclipse Sirius project.
And I'm Jan from TypeFox, and we are one of the companies behind the Xtext project. And I guess a few years ago, you wouldn't have seen two of us on stage together. We were like two different worlds, the textual versus the graphical, and it was pretty much of a fight. But recently, we joined forces and tried to get the best out of both worlds and fixing some bugs and getting things closer together. So now we're kind of cooperating on that topic. And I guess that's good news for the Eclipse community, isn't it?
Yep.
All right, this is our agenda. We are going to show you 3 examples with 3 different modes of integration of textual and graphical modeling stuff on different levels. And finally, of course, we end up with a conclusion.
So hopefully at the end of this talk, you'll get very nice, you'll see what kind of use case you could have, how you could use both technology. And I'm going to start with the first case of integration, which is about persisting the model using Xtext, right? So when you look at the kind of model Sirius is managing as a runtime technology, you have both what we call the semantic model, which is actually in this case the model from Xtext, which is your domain instances, and the diagram model. The diagram model is a .ard file, and it contains all the graphical information, like this shape element is placed at this area with these colors and so on. So these are the kind of model you find into a Sirius project, and internally it's all loaded in a single resource set. By default, these models are persisted as XML resources, but Sirius doesn't care that much about what kind of serialization is used, as long as it fits with the EMF contract. And Xtext provide an Xtext resource which just, from the Sirius point of view, it's just a classical resource. We can load it and get the contents and get the fragments and all this stuff. But behind the scene, it's actually using the Xtext API and infrastructure to use the grammar and load it and save it using this grammar, which means from a Sirius point of view, it's pretty transparent. So I'll show a quick demo. So here I have an environment, an Eclipse environment. Can you see it? Okay. And it's containing both Sirius, Xtext, and the specific plugins to integrate Sirius and Xtext, right? So I'm going to create a new modeling project, which is a project for Sirius. And this project contains the ARD file, which is going to contain diagrams and stuff. And if I just take an Xtext file and put it into the Sirius project. So this is a state machine DSL built with Xtext. And if I click on it, it's going to ask me to add the Xtext nature. Of course, I want to add the Xtext nature. So it's an Xtext file in DSL, the classical one from the samples. But it got recognized as a model for Sirius. So you can see that Sirius already loads this and sees the diagram content, the model content, sorry, directly into the project as well. So when you use Sirius, you start by enabling some viewpoints, and depending on some viewpoint, you have access to different kind of representations. So here, one viewpoint has been defined for the state machine, and it's actually a state machine diagram. So once I enable the viewpoint, I can just create the diagram. The way the state machine diagram is defined is completely identical with any other kind of model. There's no serialization concerns at this point. You just define it using Sirius the way you use Sirius for any other kind of modeler. So what is interesting is that they're both using the same file, right? So here we have a graphical representation of this. And let's say, for instance, that I add a state here. And let's add a transition, for instance, on this event. And if I save, this state just appeared here in the Xtext file. And the other one also works, right? If I rename something here, like the state is active, and I renamed it, and then the diagram gets refreshed and the element is renamed here. And of course, if I do the same and rename an element here, Eclipse Con Europe, and I save, it's renaming the element, and it's even renaming all the graph references. So you can see in the DSL that the model graph is kept consistent.
So it looks like we're ready. I can go? Not quite.
So there are lots of stuff that you have to think about, because when you're actually using Xtext, you end up in some states which, from a serious point of view, are inconsistent. So let's say I'm starting to type, and I'm like, yeah, stay like that. So if I save here, it's going to trigger the refresh in Sirius. So let's see what happens. So the model is actually not possible. And if I save, the diagram gets refreshed. There's no such elements because there's a syntax error, and so I lost all my diagram information. And there's lots of work behind a diagram, right? The user did layout and placed everything. So that's really something you want to avoid. But Sirius provides some strategies to deal with that. So let's get back to the previous state and save. And if I just change a preference, a Sirius preference, and say, hey, I don't want you to automatically refresh, I want to control the refresh. You could control it either by user interface or by some specific code. Then the behavior is going to be slightly different. If I start editing and I save, then all the corresponding shapes in Sirius are identified as unavailable. So I can't edit the diagram. It's just, these are locks, but it's just marked as, hey, the information is there. So if I want to, if I hit refresh now, it's going to remove it, but I am in control. If I get back to a state where the element is available, then it's going to work the same way as it used to work right before. Okay? So let's continue with the presentation. So that's the easiest integration strategy, but I said you have to think about the refresh, right? And probably set up a specific strategy to decide when this diagram gets refreshed so that your user don't lose their layered information. So that was a concern you might have. So grammar-defined constraints regarding a set of characters, and you can end up in a situation where the model in memory does not meet those constraints. So that means that in that case, the grammar is unable to save and serialize the model. And this can happen if you edit the model in memory in Sirius and you want to hit save, and then Sirius is going to provide you a pop-up like, hey, it's not possible to save this model. And then the user has to get back to a serializable state. So there are a couple of strategies to avoid this situation. The first one is when defining the graphical tool to make sure that you go from, as much as possible, that you go from a serializable to a new serializable state. For instance, if you create a new state instance in the diagram, it's probably better to just set a name by default so that if the user hits save, it's possible. You could also loosen the grammar a bit and provide stricter validation, and then you can always serialize and get feedback when there's a problem. And it's generally good practice, to highlight the offending elements in the diagram, so that if, in this case, the element has no name, it's red, and so the user can quickly identify where he has to fix the model. Another concern is that when both editors are actually only synchronizing through the file systems, you can have situations where the user started to change something in the textual editor, but started to change something in the diagram editor, and stopped. And when he hits save on one or the other, well, actually, at some point, you have to make a choice of either reloading from the file system or from the current in-memory state. So you need some kind of synchronization so that the user, for instance, when he's in a single editor and he moves from the other one, he can't do anything without the first one being saved before. So let's get to the second use case.
Yeah. That is references between Xtext and Sirius models. This is the example that Cedric is going to demonstrate again. We have a couple of models in this case, textual models and graphical models with cross-references in between, and there's even a CSV model inside, so please go on.
Yeah, get back to the proper default settings. So in this project, I have a couple of files which are considered as model. I have XMI files, and I even have a CSV file which is like loaded as model. So Sirius doesn't care that much about how the data is serialized. But more interestingly, I have here a model to describe a form, an exploitation. And I can describe it in terms of workshops and fields, and each field has different size depending on whether the field is irrigated or not. The color is going to change, the size of the shape is depending on the size of the field and stuff like that. So it's a pretty good use of a graphical modeler. And on the other hand, I have an Xtext DSL to define what kind of culture can be done and what is a farming culture. So if you want to cultivate corn, for instance, there's a couple of activities related to that. The first one being the labor, using, well, you need one tractor and one person, and the second one will be sow from this time and so on. So this level of details and level of flexibility is really requiring some textual DSL. You definitely don't want to define such rules using a diagram. And you can then definitely use Xtext for this. So that's very good usage of the text. But then these cultures, I want to refer to it, and I want to say, hey, for instance, this workshop is going to, this group of fields actually is going to be dedicated to the wheat culture. So you can see in this diagram that we are displaying elements which are coming from the Xtext file in the same diagram that we're displaying elements coming from the XMI file. Sirius doesn't care where the elements comes from. You can write a query and get the elements from somewhere else. So if I double-click, for instance, I can navigate to the corresponding port of the Xtext DSL if it's not stuck. Okay. So this is really a nice use case of having both worlds, but it requires quite a few concern and tweaks that Jan is going to speak about now.
Okay. So one thing you have to know about EMF, EMF supports cross-references between elements. So usually an EMF model is a tree, but if you want to refer to something that's in another tree or in another position of the tree, then you have to have a cross-reference. The cross-references are usually allowed across file borders even, and even across different resource implementations. So it looks like everything is there and everything is ready, but there's a slight trick to it. A cross-reference in Xtext, in EMF, is usually defined by the URI of the referred element. And the URI contains the name of the file where it is in, a hash mark, and then a fragment, which is like the identifier inside the file for that specific element you're referring to. For example, there's this bar, in this file bar.y, there could be an element with such a fragment. That holds for all EMF models and XMI. But there are differences in the way that graphical and textual tools are using cross-references. I'm giving this talk with Cedric.
Well, and I'm giving this talk with EC 2017-116, right?
That's actually really my technical ID in the Eclipse Con registration system. So you see there's a difference between the way we refer to each other. One was by name, and the other was by a technical identifier, in this case a URI. And a URI consisting of some resource and a technical identifier. There are a lot of differences due to that fact. The first one is, to resolve Cedric, the name, to the person Cedric, I need a certain resolution mechanism. I need something like a lookup table The lookup table could be pretty specific to the use case where I'm currently in. It is not something that is an inherent property. It's not easy to do this. And in a different context, it could be a completely different person. On the other hand, we have that EC 2017 hash 116 that is easily resolvable by the system because that's the technical ID. But this one introduces a coupling of the resource name, ECE 2017, to the identifier. That resource name, actually I had to change that because we gave the same talk at Eclipse conference. There was ECF to 2017. So we changed kind of the resource where the element Cedric resides in. And the name of that resource, the file path if you want so, is part of the ID, which is not the case here, but this also means that I have to provide the context from the outside. So what is my set of names I can refer to? Syntax errors are completely part of the game in textual DSLs. When I type, most of the time the model is broken, and the same holds for cross-references. When I just write the wrong name, there is no problem. While when in a URI-based system, I usually not exposed to these kinds of identifiers. They are hidden because it's not easy for humans to deal with them. So if I have an error in here, so if I kind of break the consistency rules of my cross-references, I'm going to have a pretty hard time fixing that bug. A rename is a complete different operation in a name-based system than a URI-based system, because in a URI-based system, a name is just a property of an element. I can change it to whatever value I want. But when I change the name on a name-based system, I have to make sure that everyone who refers to the object by that name also updates that reference. This is called a rename refactoring. So that will affect a lot of resources, while in a URI-based world, I just change one file. And of course, I mean, you may have noticed no one would talk like this, so I would be a bit reluctant to be called ECE 20 or something, you know? So people usually use names to refer to things, and this is why most programming languages use names and linking and scoping and all the like. So this is usually something you hide from the users, the technical IDs. So that is one difference. The other difference is how the models are managed in memory. In Xtext, whenever I open a DSL file, the editor gets its own resource set, and within this resource set, it loads the file, the resource that I want to edit, but also everything that it refers to, all the dependencies. That means that this editor here loads foo-DSL, but this one for bar DSL also refers to foo-DSL, so I have two instances of these guys at the same time in memory. That's not the case in Sirius. Sirius holds one big resource set for all resources that are shown in the diagrams. So I have a single instance of that foo-DSL inside the entire project. If I change that one, it will be reflected in the entire model, in the entire diagram world of that project. This also makes a big difference when I now change foo-DSL here. I have to make sure that this editor kind of gets updated. And Xtext has a special mechanism for that, a dirty state mechanism to synchronize the dirty states between the editors. There's no need for that on the right-hand side because everyone is using the same model. So they share the same dirty state. Last but not least, what was the last one I wanted to say? Let me think about that. Transactions, yeah, sure. A resource set, the big one like this one, has shared transactions. That means if I do a change to some of the models, I can even touch all of them at the same time. Inside a single transaction, I share a single transactional space. But here on the right-hand side, I have transactions per editor. That makes a big difference, okay? This is also something I don't like so much about graphical tools is when I do undo, I undo the last operation on the entire model, and it may not relate to the current diagram at all. So it may be something that's visible somewhere else. That can happen there. That won't happen in textual DSLs, but then you have to kind of sync the transactions between the various editors. So I see that there's a lot of friction in the way we actually deal with EMF. It's all EMF. It gives a good integration as long as everything is consistent. But there's a lot of friction when it comes to dirty states, transactions, changes, renames, and so on. So we have to make sure we take appropriate countermeasures. And this is what you have to do when you want to make Sirius refer to Xtext, which is always the case if your diagram model refers to an Xtext resource, because the diagram model already has a cross-reference to the semantic element it shows. You have to implement an ifragment provider on the Xtext resource. That is, you have to customize the strategy which the identifiers inside the resource are calculated. They should contain the name, because you are likely changing orders of element. For example, in the state example, you could change the order of states. That would break the correspondence on the diagram side. You don't want that. Second, you want to implement Xtext support for AirD files. That mainly means that you make them indexable. Xtext can only refer to things that it sees in its index. So you have to make sure these AirD files are part of that index. We have done that for the examples, and you can download the solution if you want to do something like that. That also allows Sirius to take part in rename refactoring, as we've seen in the first example. So if I rename an Xtext element, the references to it are automatically updated. And you want to, of course, have that correspondence for the user, so we want to navigate from one representation to the other. That doesn't come for free, but is feasible if you know the APIs of either framework. And what you have seen a couple of times already is you have to define fixed synchronization points, because a broken model in the textual world can mean that the entire semantic model that the diagram refers to is gone, or at least large parts of it. And you don't want to make that automatically delete the diagram representations. Fixed synchronization points, on-safe, and maybe even a further one, as Cedric showed with the refresh strategy. Okay, then again, you can try to get some safety with using a compare and merge approach. So there's EMF compare. If something is no longer findable, if a reference is dangling, you go for EMF compare and find something similar, or try to find out why that happens. I personally don't like that approach so much, because it brings a bit of magic into something that should be strictly consistent. But I heard that you did very good experiences with that approach, so maybe I'm just a bit prejudiced.
We had pretty good experience, but it definitely requires to test and make sure that the corresponding DSL is completely supported by EMF compare, so that you don't end up with the model not being reloaded correctly. So.
Okay, that's aside from Sirius cross-references to Xtext, and then there's the other direction. How do I make Xtext refer to Sirius or other XMI resources? Well, you have to implement the XMI support, like I did for the set for the AirD files, make them indexable, make them referable. That automatically makes cross-references openable to a certain extent, and allows the participation in rename refactorings triggered from the Xtext side. You have to implement that navigation direction, and rename on Sirius side must trigger rename refactoring in Xtext, which is one of the trickier parts here. So we did all that in these examples, and if you really want to do this, you can have a look at these or ask us how we did it. Either way, if you want to have cross-references from Xtext to something, you need to have these resources indexed, and that usually requires to set up a small dependency injection container with all the required services from the Xtext perspective. When you do that, you may run into problems that things are indexed or not, and not referable and the like. So there's a little tool inside Xtext that allows you to browse the index, to put queries against it. It starts with Control-Shift F3 or Command-Shift F3. Open model element, it's called. And after all, dirty state integration, that means the state of unsaved editors. Dirty state synchronization is really tricky, because it's completely different with the resource set multiplicities, and because the EMF model is kind of a result, a parse result for Xtext, and not a first-class citizen. Okay, that's it. I guess that's the time for the last example.
Yeah, so we've seen how we can use Sirius and Xtext where Xtext is used for the serialization. We've seen how we can use Sirius and Xtext where we can cross-reference elements from the one to the other one. And now I'm going to show you another use case where we're actually using Xtext to provide some tooling, because just from a grammar you get a complete IDE, right? So in this use case, we are embedding Xtext into a single diagram editor. So we're actually using a grammar from Xtext to define a DSL, and this DSL is mostly used to provide some nice assist and tool validation directly into the diagram editor. But the values of this DSL are actually just stored as a string within the tool, right? So this is a pretty common use case also. I'm opening the project right there. So it's a DSL representing system, basically representing systems. And so that you can define a system as a composition of subsystem, which might contain some processors and have some sensors, for instance, providing data in and out, and all these being processed. This diagram can allow you to define the system and check all the constraints. For instance, if we have a back camera, and let's say that I'm going to change the volume of data which comes out of this camera, and I'm going to increase it pretty dramatically, then I can directly see from the diagram reaction that, oh, okay, this GPU is at the high usage level and so on. And I can also check that the temperature, for instance, is getting higher than it should be. And then maybe just add another fan and get back. Well, so that's basically the kind of tool that we usually build with Sirius. But here, we relied on the new support for the properties used in Sirius, which are there, and we contributed a new tab, which is called routing here, which allows to define rules regarding the systems, what happens, what should happen when something goes wrong, for instance. And here, this widget is actually a specific widget we did develop for the example, but it's like 200 lines of Java code. It's all published and so. And if I select this subsystem, then I can just call the code assist and define different rules. Like, for instance, what if the central unit system temperature is higher than, I don't know, 50 degrees, then will trigger some kind of critical alert. So, of course, this is a very basic use, but Xtext provide all the tooling. I got the code completion. I've got the syntax error, for instance, here, and so all these tooling is coming pretty much for free once you use Xtext and the grammar. And so it's just a string attribute. You don't couple some different DSL. And I can even just look at it from the project explorer. And if I look at it, I still have this tab here, and it's pretty easy to implement navigation so that I can get back to the diagram and just by control click select and reveal the corresponding element.
Yeah, so the cool thing in this case is that this model behind the Xtext part is only volatile and gets parsed only if you need it, but it's still, of course, an EMF model. The trick behind it is some class we provide with Xtext. It's the embedded editor widget. There's an SWT widget, but you can put in everywhere in your SWT applications, like in the property view here, and that will run an Xtext editor inside. That needs a certain context and the like, so you have to configure that, and that's the 200 lines of code that you were talking about. Once again, you have to sync transactions. I mean, yeah, of course you can save that text to a text attribute when it's broken or not, but you have to be careful a bit when you do this and whether you want to do an additional validation on that. The tricky part here was that this editor widget has to refer to, it had references to Sirius, so it has to refer to the unsafe state, the dirty state of the Sirius part. We did a a trick here in Xtext, we actually refer to an external resource set. We have such a class in Xtext. It's usually not provided by EMF, but it works fine in this case. But when you then start name refactoring from within the text widget or from the outside, things are going to get a bit tough. We haven't done that for the example. I guess you could do it. You could come to a little better tooling here, but maybe this is the point where you have to say, stop, it's enough, all right? You won't get it to a perfect state, but to a very good one. So here's the conclusion. You can integrate both. It's really EMF behind it, behind both of them. And my pointer is gone. Could you could you switch to the next?
Okay.
Okay. Yeah, maybe just do it manually.
Well,
Doesn't.
let's do it that way.
Okay, let's show this one. It doesn't matter. So the basic integration layer is EMF. Xtext produces an EMF model, and to the outside it looks like EMF. All right. And that is quite easy. You see in that first example, there was not much we had to do. It's like set up a plain Xtext project, and most of the stuff already works. So there were little tweaks which are shown in the code if you have a look at it.
You can really get the best of both worlds, right? It's possible, and yeah, as Jan said, the basic level is quite easy to achieve.
But the deeper you want to integrate, the more tricky the details get. So there are pretty large differences in the way cross-references are handled, transactions are handled. We use resource sets and multiplicities of element and to handle consistency. So these are really sometimes a bit of a mismatch. You can try to make a very safe tool, and that is possible to a large extent. And I guess we've shown a lot of good examples where users would be very happy with, but you'd never get it to a really perfect solution.
Yeah.
But
so
very close.
Very close. And one of the good news is also that Obeo, which is behind Sirius, and TypeFox, which created Xtext, we are both partners, and we're actually providing a joint offering of expertise. So if you have such a use case and you want to meet your goals, then it could be a good idea to come to us, and you can get the experts from Sirius and Xtext working together and helping you getting where you want to go. So all the examples are online. I'm trying, wow, it's weird. Anyway, so it's all online. All the source code, everything you've seen, it's all online. It's only based on open source stuff. The follower DSL, and there is the farming, which comes from the Gmark project, the flow designer, it's all there. So Jan also wrote a specific blog post telling about linking Xtext models with EMF model, which is, well, completely relevant to such cases.
It's very technical, but complete.
And we also are publishing a white paper, which is coming very soon, probably this week or something like that, which is Sirius and Xtext integration and the main use cases. So if you're interested in such a document, just come to us at the booth and give us your info, and we are going to send it to you as soon as it's published.
Yeah. So all that's left for us is to say thank you. Don't forget to evaluate the sessions. Maybe you have one or two questions? No question? I guess everybody's hungry. Oh, okay. So the question is whether the integration depends on the grammar itself. Basically, it's, well, from a high-level perspective, it's generic, independent. We had one slide showing you several tricks to make the grammar more resilient to errors that could come from that. Like, you know, not having, rather having optional elements in the grammar, and maybe relaxing the syntax rules for certain terminals and the like. That is something you should take care of, but in general, it's not related to the grammar. It's the infrastructure with the fragment provider and the like, which you may have to tweak, but not the grammar. Okay? Yes, one more.
Well, so the question is, do we have a way to get the Xtext validation back into Sirius? Well, yeah, it's actually not too hard to, because in Sirius you can configure specific validation rules and stuff, and so you can just delegate it and get the information back from Xtext and provide it to the user. So it's definitely doable. You could even decide to display it with marker or something else, right? Could be using the shape or color or whatever.
Xtext uses the standard EMF way of validating. It hooks into that one, so it should be feasible.
Yeah, by default, yeah.
More questions? No? Okay, done. Thank you for your attention. Have a nice dinner. Enjoy the rest of the conference. Thank you.
Thank you.